Welcome to Statics Lectures by Civil Thinking, and today we are going to see another concept, and the concept is resultant of force systems. Now before I move on, I suggest you to please watch the video lectures one by one as in the playlist so that you will understand better. The playlist link is in the description, or also you can click on the pop-up on your screen. Now coming to the topic, resultant of force systems. Now what is a force system? Now as I have told you in the previous class, force system is when there are more than one force acting on a body, then all of those forces combined together, we call them a system of forces. So basically it is more than one force acting, okay? Now if you want to know more about force systems, I have already made a video lecture. You can watch that video lecture by clicking on the pop-up on your screen. Now I will tell you briefly. For example, we have a simply supported beam like this. Okay, this is a simply supported beam and it have multiple forces like this. Now because there are more than one force acting, so all of these forces, it is known as a force system. Okay. Now what is the resultant of force system? Now as you can see here, there are multiple forces here. Now when we add them up, okay, we will add them as vectors and we will get a single vector, right? We will get a single force. For example, this is F1, this is F2, and this is F3. Now when you add F1 plus F2 plus F3, you will get a single force, okay? It will be somewhere here and I will denote the resultant with R, okay? Now in this lecture we will see how to find this R resultant vector, okay? Now based on the type of force systems, we have collinear force system, parallel force system, concurrent force system, non-parallel, non-concurrent force system. Based on each type we use different method, okay? Now in this class we will see how to find the resultant of these three, okay? This and this, and the resultant of non-parallel non-concurrent force system, we will see about this in another class. Now let's go. Now let's first find resultant of parallel force system. Now parallel force system is, for example, you have a body. For example, this is a beam, okay? It is supported here, okay? Now if the forces acting on it are parallel, okay, like this is one force, this is second, and this is third force, okay? Now these three forces are parallel. Why they are parallel? Now if you draw the line of action of this force, it will be like this. Excuse my handwriting, I am trying to draw it straight. Please assume it to be a straight line, okay? This is the line of action of this force, and this is the line of action of this force, and this is the line of action of this force, okay? These are the line of actions. Now because the line of action of these forces are parallel to each other, right? They are parallel to each other, that's why it's known as parallel force system, okay? Now how to find the resultant of these? Now summation of forces along a direction is equal to resultant. This is not zero, it is resultant R, okay? What we are going to do, for example, this is a beam, this is F1, F2 and F3. Now because they are all vertical forces, we will add all the forces. Let us say the vertical direction is y direction, it will be equal to resultant, okay? This will be the first step, and the second step will be movement of forces about a point is equal to movement of resultant about that point. Now for example, let us say this point, okay? Now the movement of all these forces about this point, all these forces F1, F2 and F3 is equal to, now resultant will be, for example, if it is here resultant, then the movement of this resultant about this point, they will be equal, okay? Movement of F1, F2 and F3 about this point will be equal to movement of resultant about this point or anywhere, okay? For example, this point. Now movement of F1, F2 and F3 about this point will be equal to movement of resultant about this point, okay? So we will apply this moment of forces is equal to moment of resultant. Okay, you will understand everything when we solve this example, so don't worry. Yeah, of course it is about a particular point. Okay, about a particular point. Now moment of forces about one point is not equal to moment of resultant about another point. The point has to be same. Okay, then the moment of forces is equal to moment of resultant. Now you will understand this all two steps in this problem. Now here we have the problem. Find the resultant of Fourier system shown in figure. This is the figure here. And also find its distance from point B. Okay, now we have to find the resultant of Fourier system, all of this. Okay, now if I assume the axis like this, let us say this is x axis and this is y axis. Okay, now y axis upwards is positive and x axis to the right, this x axis is towards right, this is positive, and this y axis is upwards, this is positive. Okay, I am making the assumption like this. Okay, now if there is a force like this, it will be positive because it's in this direction. Now if there is a force like this, it is opposite to this direction, so it will be negative. Now if a force is like this, it is in this direction, it will be positive. If a force is in this direction, it is opposite to this, so it will be negative. So let us say now here we can see they are all vertical. Now this is y-axis. Okay, the vertical is y-axis as you can see here. So let me apply summation of f of y is equal to resultant. Okay, now upward forces, as I have told you, it is positive, so 10 plus 20, 10 kilonewton plus 20. Now this is minus 8, right, because 8 is downwards, is equal to resultant. Now this is 10 plus 20 is 30, minus 8 is resultant. Now 30 minus 8 is 22. Okay, so here we get the magnitude. Okay, this step gives us the magnitude of resultant, right? Magnitude of resultant. So we get the resultant to be 22, of course, kilonewton, right? Now the second part of the question is find its distance from point B. Now this is the point B. Okay, we have to find the distance of this resultant from point B. Now as you see, this R is 22 kilonewton, right? Because it is positive, right? This is positive. Now positive is which direction? It is upward, right? Because I have already told you the upward is positive. It means the resultant is upward. But I don't know the location right now. So let me assume the location here. Let us say this is resultant, which is of course 22 kilonewton. I don't know exactly if it is here. We will see. Now we have to find the distance of resultant from B. Now let's assume it is at a distance of x. We have to find the distance of resultant from point B. So I assume the distance is x. So let's apply the second step. This was first step. What was the second step? The moment of forces about point B is equal to moment of resultant about point B. Okay, so let's find the moment due to the forces. Okay, now moment due to this 8 kilonewton about point B. Now I am making an assumption the clockwise moments are positive. Okay, the clockwise moments are positive, and of course the anti-clockwise moments will be negative, right? Now 8 kilonewton, as you can see here, it is going to exert a moment like this, right, at B, this 8 kilonewton. So it is going to be positive, right? So I will write 8 multiplied by, how much is 8 kilonewton far from B? It is 2 meters, right? So 2. Now we found the moment due to this. Now moment due to this will be what? 10 multiplied by 2, right? Because 10 kilonewton is 2 meters far from point B, right? So it will be, again it is going to exert clockwise movement like this, so it is going to be positive. So I will write plus 10 kilonewton multiplied by 2, right? So I have also found the moment due to this. Now moment due to 20 kilonewton about point B is 0, right? Because the distance is 0, 20 kilonewton is passing through B, so we will not consider this, okay? Because moment due to 20 kilonewton at B will be 0, okay? So we have to find, this is the, all of this is moment due to forces, right? Now it has to be equal to what? Moment due to resultant. Now here is the resultant and it is x distance far from point B. Now resultant is upwards and it is going to exert movement like this, which is anti-clockwise, so negative. So minus 22 kilonewton multiplied by x, right? X. So it is 16 plus 20, right, is equal to minus 22 x. Now this is 16 plus 20 is 36, right, is equal to minus 22 x. Now from here I will get the value of x to be what? Negative 36 divided by 22. Now let me use a calculator. How much is it? It is negative 1.63. Okay, we get this x to be minus 1.63. Of course the distances are in meters, so it will be in meter, right? So what does it mean? Now if it was 1.63 meters, the positive 1.63 meters, so we would say the resultant here it is at a distance of 1.63 meters, right? But here we have a negative sign. The negative means the resultant is not in this side of B, okay? It is basically in this side, opposite side. Negative means opposite, so the x is here, okay? It is 1.63 and not this, okay? This is 22 kilonewton. So what is the answer? Answer is 22 kilonewton upwards. Yes, of course it is upwards. It is 22 kilonewton and 1.63 meters to the left of B. Yes, it is, this point is to the left of B, so answer is here. Now I hope you understand. If you have any doubt you can comment, and let's move on. Now let us see about resultant of concurrent force system. Now what is a concurrent force system? Concurrent force system is if the line of action of all the forces meet at a single point or they intersect at a single point. For example, if you have a force like this, then you have force like this, and you have a force like this, right? Now all of the forces they meet at this point, they intersect at this point, or the line of action of these forces intersect at a single common point, so it is known as concurrent force system, okay? Now we have to find the resultant of this force system. Now we have multiple methods: parallelogram law method, polygon method, and method of projections. Now parallelogram law method is used when there are only two forces, okay? Two forces in the force system. Two forces, then we use parallelogram law method, and these two are used when we have more than two, okay? More than two forces. All right. Now what is parallelogram law method? Now you might have seen the parallelogram law. If you don't know about parallelogram law, please watch my video lecture on parallelogram law, and I will explain it in a brief here. Now if we have two forces, two concurrent forces, F1 and F2, okay, they are making an angle theta with each other. F1 and F2 are making angle theta, okay? Then the resultant will be somewhere between them, okay? This is F1, this is F2, so resultant will be here somewhere between them, okay? Let us assume the resultant is making an angle of alpha with F2. Then the resultant is under root of F1 square plus F2 square plus 2 F1 F2 cos theta, and the alpha, okay, alpha is tan inverse of F1 sin theta divided by f1 cos theta plus f2. Okay, now if you don't know about where did I get this, I have already made a lecture on parallelogram law. You can watch that. Okay, so let's solve a problem, you will understand. Okay, here is a problem. Find the magnitude of resultant force shown in figure. This is the figure. Also find the angle between the resultant and the 10 kilonewton force. This is 10 kilonewton, and we have to find the angle between the resultant and 10 kilonewton force. Okay, now according to parallelogram law, the resultant will be somewhere between them. Okay, now here the theta is how much? 60 degree. Okay, now resultant will be somewhere between them. Let us say this is the resultant. We have to find the magnitude of resultant. Now what is the magnitude of resultant? Whole under root of f1 square plus f2 square plus 2 f1 f2 cos theta. Okay, theta is the angle between them. Now let us say this is f1, 15 kilonewton is f1 force and 10 kilonewton is f2 force. Okay, now let's put the values. It is going to be 15 square plus 10 square plus 2 times 15 times 10 times cos theta. Now how much is theta? 60 degree, right? Cos 60 degree. So when I use a calculator, so let me use a calculator. 21.79. okay, 21.79, it is kilonewton, right? So of course it will be in kilonewton too. Okay, so we get the magnitude of the resultant to be 21.79. okay, now let's find the angle between the resultant and the 10 kilonewton force. So this is resultant. Okay, it is 21.79 kilonewton. Now we have to find this angle between 10 kilonewton and resultant, right? Now we know alpha is what? It is tan inverse of f1 sine theta divided by f2 plus f1 cos theta, right? So let me put the values. Alpha is tan inverse of what is f1 is 15 kilonewton, 15 sine theta is 60 degree divided by f2 is 10 kilonewton. Okay, f1 is 15 cos 60 degree, right? So let me use a calculator. Okay, I get alpha to be 36.58 degrees. Okay, so this is the angle, 36.58 degrees. Okay, now I hope you understand. This is the way we find the resultant of concurrent forces, but when there are only two concurrent forces. Okay, now how to find the resultant when there are more than two forces, and I have told you there are two methods to do that. Polygon method, as I have told you here, polygon method and method of projection. Now in this, the method of projection is important. Okay, because it's used and it's very easy to use, and you get the answers very fast with the help of method of projections. Now the polygon method is not used so much, but I will just explain it with a brief example so that you will understand it, but it's not really important. Okay, so let's move on. Okay, now in the polygon method, forces are joined head to tail to form an open polygon. Assumption is force is equal to length. Okay, you will understand this with the help of this example. Find the resultant of force system shown in figure 1.4f using the polygon method. Now in this is a problem here. This is concurrent system. As you can see, they are all intersecting at this point, right? So this is a concurrent system. And how to find resultant using polygon method. So we will join the forces. For example, this is f1. Okay, f1 is 10. Then we will join f2 to the tail of f2 to the head of f1. Okay, for example like this. Now f2 is 20. Then we will join F3 here, tail of F3 to the head of F2. F3 is 10, right? 10. Then we have F4. F4 is 20 kilonewton, right? Now we join them. As you can see here, it is a polygon. Okay, we have something, we have a figure like this. This is like some polygon, right? Now this end is open, and this open end will be the resultant. Okay, I will show you here. From head will be the tail of resultant, and to the tail will be the head of resultant, right? This will be the resultant. Okay, now we have to assume, for example, 10 kilonewton is 1 centimeter. Okay, we are representing forces in terms of length. Okay, so we assume 10 kilonewton is 1 centimeter and we draw it. Okay, so this is 10 kilonewton. Let us assume, so because 10 kilonewton is 1 centimeter, so let's assume from here to here it is 1 centimeter. Okay, then 20, when 10 kilonewton is 1 centimeter, it means 20 kilonewton is 2 centimeter, right? So let us assume from here to here it is 2 centimeter. Okay, now 10, let us assume from here to here it is 1 centimeter. Why? Because 10 kilonewton is 1 centimeter and this is 20, so let's assume from here to here it is 20 is what? 2 centimeter. Okay, so now what will be the resultant? Resultant will be this, right? This side will be the resultant, right? Now when you have to measure the length of this line, okay, you have to measure the length. So whatever you get, for example, you get the length of this to be 4 centimeter. You measure it with a centimeter scale, centimeter rule, and you get 4 centimeter. Okay, now 10 kilonewton is 1 centimeter. So how much is 4 centimeter? Will be 4 multiplied by 10 kilonewton, right? Which is 40 kilonewton. So 4 centimeter is 40 kilonewton. So this is 40 kilonewton, right? This is 40 kilonewton. So we get resultant to be 40 kilonewton. Okay, so this way we get the resultant of this concurrent force system. So I hope you understand this polygon method, and as I have told you before, this is not really important. So let's move on. Now, method of projections, as I have mentioned here, it is very important. Now forces are resolved along two normal axes, and then parallelogram law is used to find the resultant. Now in this method, what we do, we resolve the forces along two axes, okay, horizontal axis and vertical axis, for example. Then we add those components. You will understand everything. Then we use parallelogram law. You will understand everything in this example. Now find the resultant of force system shown in figure. Now this is the figure here, and we have to find the resultant using method of projections. Okay, now let's assume this is x-axis and this is y-axis. Okay, now this is 6 kilonewton. Okay, and it's making 30 degrees angle. Now from here it will be, if I find the component of 6 kilonewton, if I am resolving the forces, you know about resolving the forces, resolution of forces. If you don't know about resolution of forces, please watch my video lecture on how to resolve forces. Okay, how to get the components of a vector. You can click on the pop-up on your screen to watch the video lecture. Now the component of 6 kilonewton in y direction will be 6 multiplied by cos 30. Okay, because the angle is 30. And the component of this in the x direction will be 6 sine 30. Okay, 6 multiplied by sine 30 degree. Okay, so we found the components of 6 kilonewton in y direction and x direction. In the same way, we will find the x and y component of each force. Now here you can see it is making an angle of 45 degree with the x-axis. So here the component of 4 kilonewton in x-axis will be 4 cos 45 degree. Okay, Now the same, its component in the y direction will be 4 sine 45 degrees. Okay, so we found the components of 4 kilonewton. Now let's come to another force. Now 8 kilonewton is already in x direction, and the component of 8 kilonewton in the y direction will be 0. Why? Because y axis is perpendicular to 8 kilonewton and the perpendicular component is always 0. Okay, so we don't have to resolve it. Now these are the forces in x direction. Now we will add summation of forces in the x direction, then we will add summation of forces in the y direction. What does it mean? We will add all the forces in x direction, and then we will add all the forces in y direction, and let us see. Okay, let's assume forces like this is positive and forces like this are positive, and opposite to them will be negative. Now 8 is positive, right? So summation of fx will be 8. Now here is 6 sine 30 degree, it is in opposite direction, right? Opposite to this, so it is negative, so it is 6 sine 30 degree, so negative 6 sine 30. Then we have 4 cos 45 again in the opposite direction, so it will be negative minus 4 cos 45 degree. Is there any another force in x direction? No, just 8, 6 sine 30 and 4 cos 45, right? So all of this, it is the summation of forces in x direction. So similarly we will find summation of forces in the y direction. Now in the y direction we have upward this 6 sine 30 degree and the upward is positive, so we will write 6 cos 30 degree upwards, and then we have downwards, so it will be opposite to this, and so it will be negative, right? 4 sine 45 negative 4 sine 45 degrees. Okay, so let me use a calculator to find the value of summation of fx. Okay, solve all of this and solve all of this. What I will get? Okay, I get summation of fx to be 2.17. I hope it's correct, I didn't do any mistake. Now let's find summation of fy. Okay, I get this 2.36, right? So summation of fx is 2.17. Of course these forces are in kilonewton, so they will be in kilonewton too, right? So summation of fx is 2.17, right? 2.17 is a positive value, right? Because it's in x direction and it is a positive value, and forces in this direction are positive. So if I draw axis like here, so summation of fx will be here. Okay, 2.17 kilonewton, right? It will be in this direction because it is positive, and positive is in this direction. Now summation of fy is positive, and the in y direction it is upwards are positive, so I'll write this is summation of fy, right? It is 2.36 kilonewton, right? Now we will use parallelogram law. Now we know this is one vector concurrent forces, this is one force, this is second force. There are only two forces, and when there are only two forces, what we do, we use parallelogram method, and according to the parallelogram method the resultant will be somewhere here, right? Resultant. Now what will be the value of resultant according to the parallelogram law? Let us say this is f2 and this is f1. Okay, now resultant is f1 square plus f2 square plus 2 f1 f2 cos theta, right? So f resultant is, let us put the values, 2.36 square plus f2 is 2.17 square plus, right, 2.36 is f1 plus 2 times 2.36 times 2.17 multiplied by cos theta. Cos theta, what is theta? Theta is angle between the two forces, right? What is the angle between these two forces? 90 degree, right? Because x-axis and y-axis, they are at an angle of 90 degree, so theta is 90 degree, which is cos 90. Now cos 90 is 0, right? So it is 0 multiplied by all of this, so all of this will be, when you multiply with the 0, this is 0, so all of this will be 0, right? So I will just erase all of this. Okay, so we are left with this, right? So resultant will be this. So let me use a calculator. Okay, I get 3.206 kilonewton. Okay, this is the resultant. Now this 3.206 is approximately equal to 3.21 kilonewton. Okay, so the resultant is, the magnitude of resultant is 3.21 kilonewton. Okay, now let us find the angle of the resultant. Now this is the resultant. Let me use the clean space. This is x-axis, this is y-axis, this is the resultant, right? Now let us find the angle of resultant with the x-axis or horizontal axis. Let us assume this is alpha. Okay, now here it is, f1, right? 2.36 kilonewton, as you can see here, 2.36 kilonewton, and in the x-axis we have 2.17, right? This is f2 and this is f1, right? As you can see here. Now, as I have told you in parallelogram method, alpha is tan inverse of f1 sine 90 sine theta, right? Because theta is 90, right? This is theta. Theta is angle between them, divided by f2 plus f1 cos theta, right? So let's put the values. Alpha is equal to tan inverse of f1 is what? 2.36 multiplied by sine of theta. How much is theta? The angle between the this f1 and f2, it is 90 degrees, so sine 90, right? And sine 90 is 1, right? Divided by f2 is 2.17 kilonewton plus f1 is 2.36 multiplied by cos 90, right? Now sine 90 is 1, so I will erase all of this. It is 1. Now cos 90 is 0, so all of this will be 0, so I will erase all of this, right? So we are only left with this. Alpha is tan inverse of 2.36 divided by 2.17. So let me use a calculator. Okay, I get alpha to be 47.4 degree. Okay, so it is 47.5 degree approximately, right? So this way we use the method of projections, right? So I hope you understand everything. Now there are a lot of problems you can solve with the help of method of projections very fast. Okay, and that's it. And if you have any doubts, please comment your doubt, and see you in the next class. Thank you.